So welcome back to working with polar coordinates. And what we've done in the previous videos is we spent a lot of time graphing polar coordinates and converting from rectangular to polar coordinate form, and then polar coordinate form to rectangular form. And the very last problem in our last video, we converted a rectangular equation to polar equation, and I want to continue to do that. Okay, so over here to the right, I've got a list of formulas. These are the relationships between rectangular and polar coordinates, and we need to use, you won't use all four of these in one problem. You typically use a couple of them per problem that you're doing, but your goal is to eliminate the x and the y value and convert that to r theta. And that's when you're going from rectangular to polar. And then when you're going from polar to rectangular, we'll do obviously just the opposite. But right now, I've got a rectangular, obviously, because I have an x in it. I've got to convert it to polar. So I'm going to get rid of the x and replace it with r's and thetas. Okay? Well, I have the relationship that x is equal to r cosine of theta. So I'm going to replace my x right here and replace that with r cosine of theta is equal to 2. Okay, so I remove the x and just substituted r cosine of theta. Now, if you'll notice, we have an equation now that has no x's and y's in it. It only has r's and thetas. But there is one more thing. We're supposed to express r in terms of theta, which basically means solve this equation for r. I need r on one side isolated. Therefore, I'm going to divide both sides by the cosine of theta. So r is equal to 2 over the cosine of theta. Okay, and that is an equation in which r is isolated and there are no x's and y's. So this was the rectangular version and this is the polar version. Notice the rectangular version looks a lot more simple. If you were to graph that, x equals 2, you just go over to 2 and it's a vertical line. This is going to be the same thing. In the polar coordinate system, you go over to 2 and there's a vertical line. Okay? But that's what's happening. Now, I didn't ask us to graph. All right? That's, again, above and beyond. So y equals 4. So my goal is to get rid of the y and replace the y with r's and thetas. So I'm going to use the fact that y is r sine of theta. So I have r times the sine of theta equals 4. I'm going to divide both sides by the sine of theta. So 4 divided by the sine of theta. And there we go. Now, again, the rectangular version here is a lot more simple than the polar version, but y'all know what r equals 4 looks like. I mean, y equals 4, sorry. It is a horizontal line at 4. Well, in the polar system, ooh, lazy. In the polar system, it looks exactly the same. It looks like that. Okay. All right, next problem. Now, notice we're starting with x's and y's, therefore this is rectangular. We're supposed to remove the x's and y's and replace this with r's and thetas, and then in the end, if we can, we solve the equation for r. So I know x is r cosine of theta, so I'm going to substitute that in for my x value. So I have r cosine of theta squared, and my y is r sine of theta. So I'm going to substitute that in for my y value. R sine of theta squared is equal to 4. Now, good news, right? We got rid of our x's and y's. We have all r's and thetas now. Bad news, we still have to solve this thing for r. That's okay, we can do this. So r cosine of theta squared means each one of these are squared, right? Because when you multiply, when you have factors inside raised to a power, each factor is separately raised to that power. So that's r squared cosine squared of theta plus r squared sine squared of theta for the same reason equals 4. Now I'm supposed to solve for r. So my next step is I'm going to factor out this common r squared that's in each of these terms. This is going to give me r squared, And this is going to be cosine squared of theta plus sine squared of theta equals 4. Any thoughts? Any thoughts at all? Is this looking a little bit familiar? Just a tad. That's Pythagorean identity, right? That's 1. So now I have r squared times 1 is equal to 4, which is r squared equals 4. And if I solve for r, I have r is equal to 2. Okay? It really would be plus or minus 2, but they're actually exactly the same thing. Let me say it this way. Okay? And that works. Yeah. We haven't talked about what the graph of that looks like, so I'm gonna hold back on that. Really, it's moving on to the next section, which is graphing polar equations. But we'll hold off on that. Okay, here we go again. Fun stuff. We've got x squared plus parentheses y plus 3 squared equals to 9. All right. Do you know what this is the graph of in the rectangular coordinate system? What does that look like? And I can't help myself. I go back to the last problem. Do you know what that's a graph of? You recognize that? That's a circle with radius 2. So if I were to graph this guy, okay, so I count out 2 in every direction. So it's going to look like that. Pretty, I know. So that means this is the same thing. In the polar coordinate system, basically, it's just the r equals 2. It's the whole r equals 2 circle filled in. Okay, now I go back to the problem that I was just on briefly. That's another circle. They didn't ask for that in this problem. I'm just talking, but this is another circle because you've got your x squared and you got your y squared, and there's your radius right there of 3. But this circle has a center of 0, -3 instead of 0, 0 like the other problem that we did. Okay, so let's see what we can do with this. That's not what we've been charged with. What we've been charged with is to get rid of these x's and y's and replace it with r and theta. Okay, so my x is r cosine of theta, but it's squared, so I have to square it on the outside. Plus my y is r sine of theta, and I still have a plus 3 I'm adding to that, and then the square's on the outside, and that equals 9. Now what am I going to do? I'm going to simplify. Okay, so r cosine of theta is r squared cosine squared of theta, just like the last problem. But here, fun stuff happening, right? We've got to expand that. That's r sine of theta plus 3 times another r sine of theta plus 3. Yes, we really do have to do this. So r sine of theta times r sine of theta is r squared sine squared of theta. Okay, r sine of theta times 3 is going to be plus 3r sine of theta. And then 3 times r sine of theta is another 3r sine of theta. And then 3 times 3 is plus 9 equals 9. All right, let's see what in the world do we have. Well, I'm recognizing some like terms right there. I know that 9 just cancels out, right? So that's gone. If I subtracted it over, you see that, right? It's gone. So there's a 0 on the right. So let's rewrite what we have. We have r squared cosine squared of theta plus r squared sine squared of theta plus, like terms, 6r sine of theta equals 0. Now something I can do here, remember like on the last problem we factored out that r squared, and then we had that fancy cosine squared of theta plus sine squared of theta plus 6r sine of theta equals 0. That's still 1, just like it was a minute ago. So that gives me r squared times 1, which is r squared, plus 6r sine of theta equals 0. Okay, and the next step, I can factor this common r out, so it'd be r times r plus 6 sine of theta equals 0. Now this step kind of bothers me just a touch. I'm dividing both sides by r. It's disturbing to me to divide by a variable, but we're assuming r is not 0. What would you have if r was 0? Well, it'd just be the pole, right? If you were graphing polar coordinates, it'd just be that guy right there. And that's not the equation of the line that we're looking for. That is not the guy you're looking for, right? So divide both sides by r. It's okay in this problem. It's disturbing, but it's okay. So then you have r plus 6 sine of theta equals 0, and now I can subtract that over. So again, what I did something that bothered me, is I divided both sides by r, and that cancels, and that's 0. But that's because that would just give me the boring graph of just the point on the pole. And that is not what this is the graph of, right? So it's the rest of it that gives us this graph. So you have r is equal to -6 sine of theta. And that is your final answer. Okay, so I subtracted the 6 sine of theta to the other side because remember that is 0 right there. And there we go. Done with that problem. Alrighty, I've changed directions on you. Okay, so this time I'm giving you a polar equation. Got r's in here. That's how you know. If you see r's and thetas, that's polar. I'm trying to change it to rectangular. So the goal is to eliminate the r's and thetas and change to x and y values. Okay, and then we have the same set of formulas at our disposal. X is r cosine of theta, y is r sine of theta, x squared plus y squared is equal to r squared, and tangent of theta is equal to y over x. Okay, you look at r equals 5 and you're like, oh my goodness, I've got to turn this r equals 5 using these equations over here into x and y values. Okay, now this is not solved for r. I don't think that's the way to go. Honest to goodness, I think the way to go would be to use this guy right here. But you're thinking, I don't have r squared. Yeah, you do. What do you do to get it squared? Square it. So you got r squared equals 25, right? It means exactly the same thing. If r is 5, r squared equals 25. Then I can use this dude right here and replace r squared with x's and y's. So I have x squared plus y squared is equal to 25. Really, that is how you do it, okay? And I know it feels weird, but that is how you do it. So x squared plus y squared equals 25. So do you remember what that is rectangular wise? So you go back to your pre-cal algebra class. This is a circle with center 0, 0, because we're not adding or subtracting anything to the y values, with a radius of the square root of this dude right here, which is 5. So again, center 0, 0, and I count out 5 in each direction. So 5, 5, 5, 5, and I'm going to attempt to draw a circle on this squirrely surface. Not bad. Okay, there it is. Now, if you were to graph this in a polar coordinate system, which we don't officially know how to do yet, so don't stress if you're not following me. Okay, I count out 1, 2, 3, 4, goodness gracious, have another one, 5. R equals 5 is just that. It would be this graph right here. Okay, which is this graph right here. 5 in every direction. This we're supposed to know how to graph, by the way. This we're not there yet. Okay, next problem. We have theta equals pi over 6. Clearly that's polar. Clearly I'm trying to change it to something rectangular and then graph it. What do we do? Okay, there's a theta right here. And if I plugged pi over 6 in there, the unfortunate thing is I would still have an r in my problem. Right? Same thing here. But maybe if I go here, I know theta is pi over 6. I could replace that with pi over 6 and the tangent of theta. And then I have y over x in my problem. And that's the goal, is to remove the r's and thetas and have it say nothing but y's and x's. So that's what we're going to do. We're going to say if theta is pi over 6, then I can say tangent of pi over 6 is y over x. And boom, there we go. We don't have any r's and thetas anymore. We have just y's and x's, and a number, of course. Now, what is tangent of pi over 6? So, unit circle flashback. What is the tangent of pi over 6? Remember, that's a y value over x value. So that's square root of 3 over 2 divided by 1/2, which is the square root of 3. And most most rectangular equations are solved for y. So you can multiply both sides of this guy by x and get that these cancel, and your final answer you could say is y, I'm switching sides on you, equals the square root of 3. Square root of 3. Try that again. The square root of 3x. Now I gotta graph that. It's linear, right? It's linear. So if you plug in 0 for x, you of course get 0 for y. If you plug in 1 for x, you get square root of 3 for y. Square root of 3 is about 1.7. Plug in 2 for x, you get 2 times 1.7, which is about 3.4, right? But basically, it's a straight line. You know this. You know this is a straight line, right? Because it's y to the first power x to the first power is linear. And there we go. Okay. Now, we're going to learn that anytime you have theta equals just a value, polar-wise, it's a straight line, right? Think about it. Let's go ahead and do this. Okay, here's your polar coordinate system, right? Pi over 6 lives right over here. There's that straight line right there. How come my rectangular one doesn't look anything like that? Because I didn't do it right. Square root of 3 is not 1.7. Gracious. What's square root of 3? About 0.7. Okay, 0.8. Alright, so let me try this again. 0, 0, still 0, 0. 1.7, 2, 1.4, 3. You just plug in points. If I would have just used my calculator or thought about that a little better, it would have looked like that, which matches our polar graph. I apologize. Alright, here we go. Convert the polar equation to a rectangular equation. We know this is polar. They didn't have to tell us that, right? Because there's an r and a theta in there. Convert it to rectangular means get rid of all those r's and thetas and make sure this is written with only x and y values. How are we going to do this? Well, if you look over to the right, by the way, you're not going to have these on your test. You know that, right? You need to know these. You need to know all of these relationships. It's actually old information. There's nothing new on this list at all. Tangent of theta equals y over x. That's been defined since the very, very beginning of your trigonometry class. Cosine of theta is x over r. All we did was move the r to the other side. Sine of theta is y over r. All we did was move the r to the other side. X squared plus y squared equals r squared. That's pretty much the equation of the circle. It's also how you found the hypotenuse. It's also the Pythagorean theorem. Okay? All right. So anyway, what do we have? That looks a whole lot like this to me. So that means that on the left, that's just y. Y'all, that's just y equals 4. This one's easy. How do I graph y equals 4? It's a horizontal line. Add y equals 4. Boom, done. Whoa, it looks like another one of those easy ones. Or is it? Check it out. I gave you a cosecant of theta. What do we do with cosecant? What do we always do with cosecant? We turn these things into sine and cosine, right? So that'd be r is equal to 2 over the sine of theta. Do you agree? The reciprocal of cosecant is 1 over the sine of theta, and all I did was multiply that 1 over the sine of theta times 2. Alright, now, I can go ahead and try to substitute, because remember I'm trying to get rid of r's and thetas to replace it with x's and y's, but watch this trick. What if I multiply both sides by the sine of theta? Before I do any substitution, I have something nice over here. R sine of theta is y, so I get y equals 2. Yay, another easy one. After you knew the trick, I know. So again, what did we do? We substituted cosecant as 1 over sine. And then we didn't like that sine in the denominator, so we multiplied both sides by sine of theta. And that gave us something we could totally work with. Nothing to it. There's y equals 2. Okay, now arrive the fun problems. Stare at this for a minute. See if you can see what to do with it. It's not what we had before. Like, I know you want to say, okay, r cosine of theta, r cosine of... No, what if the r is -4? No, no, no. It says, excuse me, r equals -4 cosine of theta. So the things that you're thinking right now, probably, now you might have it figured out, I don't know. But the things that I think originally, when I look at this problem, really just don't hold up. We can't do what I want to do quickly and make this problem easy. Or can we? Now, you can replace r cosine of theta with x. I don't have r cosine of theta. I have some other number, cosine of theta, but I don't have the variable r in there. What could we do to get the variable r in there? How about we multiply by r? Does that work? Yes, yes it works. Now I can't just multiply the right side by r where I need it. I want it on both sides. And it actually helps us that it's on both sides. So again, I'm multiplying this entire equation by r. Okay, so I have r squared equals -4 r cosine of theta. Did that help, or are you thinking, well, now it's worse? Now I still don't know what to do with it? Yes, you do. r cosine of theta right here, that's x, right? Not only that, what's r squared? Living right over here, just as happy as it can be. X squared plus y squared equals r squared. So I'm going to replace r squared with x squared plus y squared minus 4, and I'm going to replace r cosine of theta with x. Yo, we did it, right? We took an equation in polar coordinate system with r's and thetas in it. We did some little magic trick by multiplying everything by r, and now we have rewritten this thing where it has nothing but x's and y's in it. Right? Okay. Now, normally, they like the final answer to be y equals. You could do that by subtracting the x squared over. So you have y squared is equal to negative x squared minus 4x. Problem is, if you take the square root of both sides right now to get the y by itself, you have plus or minus negative x squared minus 4x. And that's two different results. So I think, actually, to me, this answer is just peachy fine. The next one down the list is peachy fine as well. That's an equation that's rectangular. Now, here's where the problem comes in. We got to graph it. We got to graph it. How are we going to graph this thing? Any thoughts at all? Well, let's take a fresh new look at it. Okay. What if we got this thing equal to 0? What would that do? Here's what I'm thinking. Okay, I'm seeing an x squared and a y squared. That makes me think circle. Is this circle-ish? Maybe. So let's get everything on one side. X squared, and the plus 4x moves over. I added him to this side, right? Plus y squared equals 0. That's exactly the same equation. Now, if I group these two guys together, because they're x's, and I complete the square, it's like, oh no. Yes, I did say that. Let's complete the square. You learned this in your pre-cal algebra class. You take half of this number and then square it and add that to both sides of the equation. All right, why in the world will we do such a thing? Okay, so take half of 4 is 2. 2 squared is 4. So I'm going to add 4 to this side of the equation. The y squared is just living there. He's happy. But if I add 4 to this side of the equation, I also have to add 4 to this side of the equation as well. Right? The 0 plus 4 is 4. Why would she do that? Okay, this factors. It's a perfect square. Multiplies to be 4, adds to be 4. What numbers do that? 2 and 2. So this is x plus 2 times x plus 2, also known as x plus 2 squared, plus y squared is equal to 4. Right? So what you got going on here is a circle with center opposite of this, negative 2. There's nothing being added or subtracted here, so 0. And the radius is 2, because this is r squared. By the way, the formula for a circle is x minus h squared plus y minus k squared is equal to r. That's an r squared. So my h was negative 2, because there's a minus in the formula. You got to change the sign. My k, there's nothing added or subtracted there, so it's 0. And this guy's r squared. I took the square root of that to get 2. I can graph this thing now, though, right? So circle negative 2, 0. So this is my center, and then I count 2 in every direction. So we're talking here, up 2, left 2, down 2. I connect the dots, and there we go. Okay? So turns out this is the best answer because we're graphing it. But y'all, there's still not really anything truly wrong with this answer. It's not. It's just not in a format that we recognize is something. Okay? This is. At least you're supposed to recognize it. Alright, so I know this video is getting long-winded, but I've only got 2 more examples. So just hang with me. I don't want to do an entire new video for 2 more examples. So what do I need to do? I've got polar equation. I'm trying to get rid of those r's and thetas and change them all to x's and y's. I scan over there at my equations on the right, and I don't see really anything that I can use. But let's use that trick we just used, right? I don't have an r cosine of theta. I don't have an r sine of theta. But I can sure make one real fast, right? I can multiply all of this by r. That will give me r squared is equal to 6r cosine of theta plus 4r sine of theta. right? I can do that, right? So r squared is x squared plus y squared. That's my left-hand side. I used this formula right here. And then I have r cosine of theta and I have r sine of theta. So the 6 remains. R cosine of theta is x, r sine of theta is y. So there we go. We have x squared plus y squared equals 6x plus 4y, which is all just peachy fine because I had r's and thetas and I got rid of them and now I have x's and y's. That'd be okay if I didn't have to graph it. But since I have to graph it and it kind of be nice to know what in the world this thing looks like, it can't stay like that. It cannot. So I've got an x squared and a y squared. I'm thinking circle-ish. This just might be a circle. How do we find out? Well, let's put it in standard form for a circle. Remember, I just threw that at you a minute ago. The standard form for a circle is x minus h squared plus y minus k squared is equal to r squared. We know this dude over here is a circle if we can write it like that. And we can, by the way. So I'm going to keep going here. I'm going to move my 6x over and my 4y over and put my x's with my x's like that and my y's with my y's like that, and that's equal to 0. Okay? Now remember, the trick is we're going to take half of this guy right here and then square it and add it to both sides. So half of negative 6 is negative 3. Negative 3 squared is 9. So I have x squared minus 6x plus 9. That's the new guy. So I'll come way over here and put plus 9. Really, it's 0 plus 9. Let me make that more clear. So the 0 is already there. Now I got that plus 9. Okay? Over here with this mess, see this mess in a different color, I have half of negative 4, which is negative 2. Negative 2 squared is 4. So now I have plus y squared minus 4y plus 4. I can't just add 4 to this side unless I add it to that side as well. Now why did I do all that? So I can factor it. Okay? Alright, so x squared minus 6x plus 9 factored is x minus 3 times x minus 3, which is x minus 3 squared. By the way, which is the half number. So whatever that half number is what you factor this into. So half of negative 6 right there. Plus, what was the half number here? Minus 2, right? That means this factors into y minus 2 squared. Or just factor y squared minus 4y plus 4, which is y minus 2 times y minus 2, equals 9 plus 4 is 13. So now we have a circle with center. Remember, you take the opposite of these signs. So the opposite of minus 3 is plus 3. The opposite of minus 2 is plus 2. And the radius is not pretty, but it's fine, the square root of 13. So I plot the center, which is 3, 2, right here. And I count out the square root of 13 in each direction, north, south, east, west. But what is the square root of 13? We know it's less than 4 and bigger than 3, right? But if you need something a little better than that, just type it in your calculator. And I've got 3.6. So I'm going to count out 3.6 every direction. Good luck with that. So 1, 2, 3, 4. So 3.6 about here-ish. 1, 2, 3, 4. So I'll come down a little bit. 1, 2, 3, and then just slightly more there. And then 1, 2, 3, and a little bit more there. And that looks all right to me. All right, last one. Promise, last one. At least you've got tons of examples. Okay, way more than the book will give you. Way more than I can really do in class as well. So I've got to do something with this r and theta. R squared times sine of 2 theta equals 4. And then you start thinking, ooh, sine of 2 theta. What am I going to do with that 2 theta? Y'all, you've got formulas for this. They're called double angle formulas. Sine of 2 theta, if you need to look it up, go look it up. Pause the video, go find it. R squared times sine of 2 theta is 2 sine of theta cosine of theta equals 4. Now, why did I do that? A lot of times okay, yeah, that's true, but why? Well, I don't have any formulas over here with 2 theta in there. I can't work with that. I've got to do something with that 2 theta. So that's why I changed it using the double angle formula. So all of this, if you look up the formula, is sine of 2 theta. Now, I still know what you're thinking. You're thinking, it still doesn't look like this over here. Let's do some fixing, okay? One thing that's bothering me when I look at it is this 2. Well, what if we divide both sides by 2? Then it poof disappears. So now I have r squared times sine of theta times cosine of theta is equal to 2. Okay, well, maybe that's better. But I got to use this stuff over here, right? I got to get rid of sines and cosines and replace it with x's and y's. Well, look, if I just had an r with my cosine and I just had an r with my sine, I'd be in luck. Well, lo and behold, there we go. Look, I've got even an r squared for you. So I can say, let's split up our r's. I can say this is r sine of theta. And then I can take this other r and put it over here, r cosine of theta equals 2. Do you agree that's the same thing? If I multiplied that back together, I would definitely get r squared sine of theta cosine of theta. Okay. And now I can say that that is y and that is x equals 2. So now I have xy or yx equals to 2. And if I wanted to go through the extra step of solving for y, I could say y is 2 over x. All right, so think real hard back to rational equations in your algebra class. And this has a vertical asymptote of x equals 0, so right here. Okay, and I plot a couple of points, so let's pick a couple of over here to graph. All right, so let's plug in -4, and that would give me -1/2. Or let's plug in -2, that would give me -1. Or let's plug in -1, that would give me -2. And what's going to happen is it's going to give me this. Okay, I have a horizontal asymptote right here at y equals 0 also. And let's plug in some positive numbers, like, I don't know, let's plug in 1, and I get 2. Let's plug in 2, and I get 1. Let's plug in 3, and I get 0.6, okay, or 2/3, and that's going to give me that graph right there. All right, tons of examples for you. Hope this helps you out.